So we're going to take a look at the state step here, and I'm realizing that I forgot to define these variables. So P sub S, we have in the STEM program versus not in the STEM program. So this is going to be the true proportion of Black and Hispanic females in the STEM program. And PNS, which I've chosen to use. If you just want to generically use subscripts of 1 and 2, you can, but you'd have to define what 1 and 2 are. I would not advise doing that. This is the true proportion of Black and Hispanic females in non-STEM programs. Now, the question asked, do we have convincing evidence that Black and Hispanic females are underrepresented? So that means this proportion would be smaller. Maybe we only have 10% in STEM, but like 30% in non-STEM programs. So a small number minus a big number leads to a negative. Now, could you have written this differently? Yes, you could have done non-STEM minus STEM as greater than 0. So that is another option. Okay, I'll talk when we get to the do step how that's going to affect things. And they told us 5% level of significance, so alpha is 0.05. So moving on to the plan step, we have independent or separate random samples of 300 and 500. Make sure you explicitly include those sample sizes. You're going to have to check the 10% condition twice. So 300 is less than 10% of all STEM students at this university. Why did I say at a library? I don't know what I'm talking about. Maybe I'm thinking about the book I need to get from the library. And 500 is less than 10% of all non-STEM students at this university. So this has got to be like a pretty large university. So because 300 times 10, maybe not that large, I guess. You'd have at least 8,000 students. That's not that crazy. Okay, large counts condition. We're going to have to check this twice. For the STEM group, 12 successes, 288 failures. For the non-STEM group, 75 successes, 425 failures. All of those are at least 10, so the sampling distribution is approximately normal. Therefore, our conditions are met. We can do a 2 proportion Z test. 2 proportion Z test. All right, going to the do step. Let me get this out of the shadow here. The proportion of STEM students who are Black or Hispanic females, 12 out of 300, 4%. Non-STEM, 75 out of 500, 15%. I have to get this combined estimate. And going back to why, we're assuming if the difference is 0, that these proportions are the same. If they're the same, we're getting a combined estimate. So overall, out of all 800 students we sampled, almost 11% of them are Black and Hispanic female students. So I forgot the sampling distribution here. This should look like this. Centered at 0. If I take the 4% minus the 15%, the way that I set this up, my statistic would be negative 11%, and I'd be shading below. If you did the opposite direction, your statistic would be positive 11%, and you'd be shading above. And hopefully you can see the graph is perfectly symmetric, so the area under the curve would be exactly the same, and your test statistic would just be the opposite. So when I'm calculating my test statistic or my z-score, taking my statistic minus my parameter, the null value, divided by the standard deviation, which comes from using this combined estimate. This formula is on your formula sheet. Now, I hope you did not make this mistake. We talked about it last week. Your p-value is a probability. It must be between 0 and 1. Being almost 5 standard deviations away from the mean is incredibly unusual by chance. That's why the probability is so incredibly low. So I hope you didn't put like 6.7 here because that's impossible. And you notice that this is in scientific notation, or you said that the p-value is approximately 0. I do much prefer putting it in scientific notation. It's very explicit communication to your AP reader and me. So then to conclude, because the p-value equals this incredibly small number is less than 0.05, your alpha level, we reject the null. There is convincing evidence that, and then just take the context, that Black and Hispanic females are underrepresented in STEM programs. You could go back to this. You could go back to the context that you wrote for your parameters, but more often than not, you're just going to strip the context right from the question. So my question to you is this. If we rejected the null, what kind of error could we have made? Type 1 or type 2? So pause the video, think on that for a second. This could have been a type 1 error. Type 1 error is when the null is true, but you reject it. So the probability we make that kind of error here is a 5% chance. So we talked about how type 1 and type 2 errors are related. So if type 1 is a bad error, we could try to decrease the significance level. Well, we could. We don't try to do it. But then that would increase the probability of a type 2 error. So just some things to think about. All right, let's move on to page 6. Same deal on page 6. When you get here, pause the video. Take some time, work through this example on your own, please, and then come back when you've worked through this. If you want to go step by step, go ahead, or just do all 4 parts. All right, here we are with question on page 6. A Pew Research Center poll asked independent random samples of working women and men how much they value job security. Of the 806 women, 709 said job security was very or extremely important, compared with 802 out of the 944 men surveyed. Construct and interpret a 98% confidence interval for the difference in the proportion of all working men and women who consider job security very or extremely important. So let's define things. P sub W is the true proportion of women, working women, who consider job security very or extremely important. P sub M, true proportion of working men who consider job security very or extremely important. All right. And I've decided to set this up as P sub W minus P sub M. Doesn't matter which way you do the subtraction. We talked about the difference earlier in the lesson. So the random condition, I have independent random samples of 806 and 944. Make sure you explicitly list the sample sizes. 10% condition, 806 is less than 10% of all working women. 944 is less than 10% of all working men. So we're sampling without replacement. We can calculate the standard error now. Large counts condition, number of successes and failures in each sample. That checks out, so the sampling distribution is going to be approximately normal. Our conditions are met. We're going to do a 2 proportion Z interval. Why are we doing an interval? Because they asked us to construct and interpret a confidence interval. Remember, state plan do conclude, never going to say that. If you only construct and interpret, you're looking at a max of probably 2, maybe 3 points out of the 4. All right, the do step. I have my proportion of women, successes out of the sample size, same for men. And this critical value, we have 98% confidence, so I'm doing inverse norm. There's 98% of the data in the middle. There's 1% in each tail. That's where that 2.326 is coming from. Times the standard error. This formula is on your formula sheet as well. 88 times the 12%, 85 times the 15% divided by the respective sample size. Plug this in the calculator all in one step. I would not encourage piecing it out, just my personal preference. My confidence interval ends up being negative 0.008 to positive 0.068. if you did men minus women, you're going to get approximately negative 0.068 to positive 0.008. Same values, just opposite signs. So, conclusion. We are 98% confident that the interval from negative 0.008 to 0.068 captures the true difference, stripping the context, in the proportion of all working women and men who consider job security very or extremely important. Okay? So for the conclusion, whether it's a test or an interval, strip the context as best you can from the question being asked. Because one thing that they're not going to do in that question is use past tense. And that by using the context from the question, you're ensuring that you're using the correct context. All right, if you do have time left right now in class, what I want you to do is go through page 7, do the whole thing, and just come back when you're done. This is kind of the be-all, end-all. Make sure you're good to go. All right, so in this one, this is kind of cool because we haven't seen a question like this before. So they're looking at the effect of preschool programs for poor children, and they designed this experiment, and they randomly assigned. And that is huge when you see this, randomly assigned. So that tells you, hopefully in your mind, you're like, oh, that's an experiment. You're right. This is absolutely an experiment because that's where random assignment comes into play. That's one of the 4 pillars of experimental design. So we have random assignment. So now what we do, we have 62 of the children attended preschool and the other 61 did not. So P sub P is the true proportion of students attending preschool who later need social services, and P sub N, true proportion of students not attending preschool who later need social services. So I just use the subscripts of P for preschool, N for not preschool. So does the study provide convincing evidence? Boom, there's your hint. Convincing evidence. This is a significance test. You don't have any part A, B, C, D. It's just a huge paragraph and then that. That preschool reduces the later need for social services. So that would mean the children who went to preschool are less likely to need social services. That's why the way I set this up would be less than 0. If you did the opposite, the null would be the same, but now for the alternative, you would have greater than 0. So conditions, random condition. This is not a random sample. Make sure you're clear and you don't just get lulled into that. The children are randomly assigned to preschool or not. Be explicit. What are the treatments? And make sure you're mentioning random assignment. Guess what? We don't need to check the 10% condition because we're not sampling without replacement. You could mention that 10% condition not needed because it's an experiment, or you just completely leave it off. Shape. Large counts condition. For the preschool group, we have 38 and 24. And for the non-preschool group, 49 and 12. There are at least 10. Sampling distributions approximately normal. Conditions are met. We can do a 2 proportion Z test. All right, getting to the do step. We have the proportion of preschool students who needed social services later was about 61%. The non-preschool group was about 80%. Because we're assuming the proportions are equal, we need this combined estimate. So overall, out of the 123 students, almost 71% needed social services later on in life. The test statistic is going to be the 61.3 minus the 80.3. That's your statistic minus the parameter. The sampling distribution is centered at 0. The difference is, I'm just doing some mental math here, I believe negative 19%. So if you set this up the opposite direction, your statistic would be positive 19%, you'd be shading above. So the test statistic ends up being negative 2.315. If you set it up the opposite way, the test statistic would be positive 2.315. To get the p-value, I'm doing normal CDF, negative infinity to negative 2.31501. If that's your test statistic, you're doing normal CDF from positive 2.315 to positive infinity 0 and 1. Your p-value is going to be exactly the same. And then the last step, because the p-value is less than your significance level of 0.05, we reject the null. There's convincing evidence that, and we're going to strip that context, preschool reduces the later need for social services. And that's it. So there's a lot here, but not a lot here. It depends on how well you feel with your structure of these state plan do and conclude steps from what we did last week and before break. So if you have any questions or you need some clarity on this lesson, I need you to send me an email so we can set up a time to get on a Google Meet this week so I can answer those questions for you, because you have your Unit 8 exam due Sunday, March 7th at pretty much midnight. So I'm sorry I wasn't there for class today. I hope that you understood this quite well and you're in good shape for that.